So here is another question on scalar triple product. So we have a vector equal to 2 I cap minus 3 j cap. Then b vector is equal to I cap plus j cap minus k cap, and c vector is equal to 3 I cap minus k cap. Okay, so again in order to calculate the scalar triple product, we'll write the x, y and z components in proper order in determinant form. 2 minus 3, no z component, so it is 0. Then 1 minus 1, then 3 0 minus 1. So here already there are two zeros involved, so no need to do any cancellation. Easily we can do it. So it will be 2 into 1 into minus 1 minus 0 minus of minus 3 into 1 into minus 1 minus minus 1 into 3, then plus 0 into whatever it becomes, it will be 0. So 2 minus 3 0, in that way I am taking. So this becomes 2 into minus 1 minus 0 plus 3, minus of minus 3 it becomes plus 3, into minus 1 minus of minus 3, that becomes minus 1 plus 3 and then plus 0. So this becomes 2 into minus 1 minus 2 plus 3 into 2, that is equal to 6 plus 0. So that is equal to 4. 6 minus 2, that is equal to 4. So the scalar triple product, a vector, b vector, c vector, that is equal to 4. Okay, this is that. So here is another question on scalar triple product. So it is given that to show that the scalar triple product of I vector, j vector, k vector, that is equal to 1, and I vector, k vector, j vector, that is equal to minus 1. Okay, so here the three vectors, a vector, let's say the first vector, it only has x component, that is unit component I vector. Then the second vector has only y component, first has x, second has y, third has z. Here the first has x, second has z, and the third has y, all unit magnitude. So the first one, if we consider the first one, I vector, j vector, k vector, that we can write it as I vector dot j vector dot k cap. Okay, I cap dot j cap dot k cap. These are all unit vectors. So we know that j vector dot k cap, that is equal to how much? I cap in cross product or vector product we have discussed. Okay, so here we can write it as I cap dot I cap, and that will be equal to 1. Okay, this is from the dot product concept. Then we have I cap, k cap, j cap, scalar triple product of them. So again we can write it as I cap cross k cap dot j cap. Okay, now we know that I cap cross k cap, that is equal to minus j. Why? Because k cap cross I cap, that is equal to j cap. So obviously I cap cross k cap, that will be equal to minus of j cap, which is equal to minus of k cap cross I cap. okay, from the rule of vector products or cross products. So this becomes minus j cap dot j cap. So that will be equal to minus 1. Okay, so we have shown that I cap, j cap, k cap, scalar triple product of these 3 unit vectors, that is equal to 1, and I cap, k cap, j cap, the scalar product of these 3 unit vectors, that is equal to minus 1. And here another rule is applicable. One of the properties that we have studied, that when the cyclic order of the vectors is changed, okay, the magnitude stays the same but sign becomes negative. That also we have studied. So directly also we can say that, but here it was asked to show, okay, to prove whether that is correct or not. So that's why we did it and we got the result. So when the cyclic order of the vectors here is reversed, the magnitude, it stays the same, that is 1, but in this case it becomes negative, minus. Okay, so this is the thing.